Hello, today I am going to talk about dimensions in physics. In advanced level physics, we use main three dimensions. They are: first one is mass. We denote dimension of mass by capital M, and we use these square brackets to denote that we use dimensions. Second one is length. Dimension of length is capital L in the square bracket. Third one is time, and the dimension of time is capital T. And using these three dimensions, we can derive another dimension of a quantity. We can find dimension of derived quantity using above three. As for example, I am taking velocity. Here I take in the dimension of velocity. We know that we can find velocity by displacement divided by time. First I take the dimension of displacement. It is a L, and the dimension of time is T. Then I can obtain dimension of velocity is Lt minus 1. There exists some quantities without both units and dimensions. As for example, coefficient of friction. Coefficient of friction, it doesn't has any unit or dimension, and the refractive index also, it is just a value, no unit or no dimension. And there exist some quantities with unit but no dimension, such as plane angle and solid angle. These two are, you know that these two are supplementary quantities. These two have units. In plane angle, we measure plane angle in radians, and solid angle steradian. But both these doesn't have any dimensions, and the dimensions are independent from the units. It is obvious that dimensions are independent from unit. As for example, I take force. The unit of force is Newton, but the dimensions are mlt minus 2. Another example, unit of angular velocity is rad s minus 1, but dimensions are t minus 1 because there is no dimension for plane angle. We can check whether equation is correct or wrong using these dimensions. As for example, I use simple equation v equals u plus at. To add two or more terms in an equation, dimension of each term must equal. Otherwise, they cannot add or subtract. So I consider the dimensions of u term and dimensions of at term. When I consider a u, I know u is a velocity. Then you have the dimensions of velocity. Then I consider dimensions of at. Then the a have dimensions of acceleration and the t have dimensions of t. Then finally I can obtain the dimensions of velocity. As you can see, we can add u term and at term without any problem because dimensions are equal in this case. Dimensions of both sides of equation must equal to be a correct equation. If this equation is correct, then the dimension of left hand side and dimension of right hand side must equal. Otherwise, equation is definitely wrong. But if the dimension of both sides are equal, but the equation can be also wrong. If a equation is correct by dimensions, we say that equation is dimensionally correct. And if a equation is not correct by dimension, then it is a wrong equation for sure. But we can't say equation is correct just by proving that dimensions are equal. Dimension of right hand side of above equation is LT minus 1. Dimension of left hand side is also LT minus 1. Then the equation V equals U plus AT is dimensionally correct. We can derive relationship between physical quantities using dimensional analysis. For example, given that the periodic time of simple pendulum is only depend on its string length and gravitational acceleration, then I can denote this relationship as below. T, capital T, this denotes periodic time, equals k times, k is a constant, L into x to the power, g into y to the power. We don't know which power of length and gravitational acceleration periodic times equal. The k is a dimensionless constant. K doesn't have any dimension. It must be a dimensionless constant. Okay. Next we going to see that how to get the values of x and y. Let's find the value of x and y through the dimensional analysis. First I am taking dimension of left hand side. LHS means left hand side. We know that left hand side there is a periodic time which has dimension of time, and I can denote this as below. I use the all three dimensions. Then it has first power of t and the zero power of length and mass. Then I am going to take the dimension of right hand side. Right hand side there is a two terms which have dimension. It is length and gravitational acceleration. I can denote that the length is a dimension of L and gravitational is a dimensions of acceleration. As you can see, they are power to the x and y. Then I can expand them as this: L to x, Ly t in t to the power minus 2y. By simplifying this, I can obtain in L to the power x plus y and t to the power minus 2y. We know that to be a correct equation, dimension of left hand side must equal to dimension of right hand side. So I am going to consider the power of dimensions, then we can find x and y. Powers of y. First I consider the powers of y. Powers of y, then I can get the equation x plus y equals 0, because right hand side the power of L is x plus y and the left hand side power of L is 0, then x plus y equals 0. I get the relationship x equals minus y. Then I am going to the power of t. Obtaining observing power of t, I can get minus 2y equals y. Then I can find the value of y. Y is minus half. If y is minus half, using the powers of L, I can obtain x value as x equals half. Now I can substitute these values to our relationship. T equals k times L to the power half g to the power minus half. And I can turn the negative power to the positive power by bringing it to the down. Then we know that the half power means square root. Then final equation I can obtain like t equals k times square root L over g. In third lesson, waves and oscillations, we get to know that t equals 2 pi square root L over G, that the constant k becomes 2 pi. But we can't achieve this in dimensional analysis. It is only a constant. We know that constant. We can't find value of constant. Like this, we can obtain relationship between physical quantities using dimensional analysis. This is a simple example and we can derive more things. In next lesson, I am going to talk about measuring instruments. Thank you.